Everybody, and welcome to episode 17. So I'm super sleepy, which means we have to do something trivial, because if I try to do anything clever I will just hurt myself, more so than I normally do. And the last time what we got to was actually getting the FK to run over the IK, so kind of like an offset to the IK. And we had started laying down the foundations for the guides. So, I had also animated this. I had no memory of doing that, but sure. Anyway, and let me remove these. Delete. So what we can start doing is introduce the guide, and I think we did a fair bit of cleanup. I did not do anything between streams or before this one. I only had a super quick glance at these, and it seems that everything is named as expected. I don't think we have stray nodes or stray connections or anything weird like that. We just need to move on with the guiding a little bit. Alright, so what do we need? We say that we want to guide the leg. Now, I believe the foot is hooked up, which is cool. I de-linked the translation of these from the actual leg global component thingy, so I might reinstate that, because that seems like a good idea. And the reason why I did it was that, well, I wanted this thing to work properly, but I also did not have the guide tracking that we added to I can do it, that we added to the leg component the last stream, and so I didn't want to have the guide and the controls actually interfering with each other too much. So let's have a look at what is going on there. I don't think we need this to fix anymore. We probably don't need these. And yeah, we don't need these either. So let's start cleaning the house a little bit. I think there's a ton of stuff pinned here, so pinning doesn't seem okay. That should be unpinned. Yep. And get the buffer couple out. So what do we have here? Leg global 2 parameters. Yeah, we're okay with that. Oh, so I did do some of that the last time, it seems. Ward ankle control SCT buffer. Leg global ankle reparent. That seems kind of dangerous the way it is right now, unless I... Okay, no, I am tracking it. So I was adding it, which means this basically would allow us, you know, if we were to hook up the guide, to restore things. So we did more work. Why didn't I even remember I had done this? Okay. We can keep that and hook these up later on. I guess we can start on the actual leg guide proper. So what do we want to do? Well, I guess the first thing that we do want to do is get ourselves some controls to move things around. Not a fan of circles in general, except for when I have some control of some sorts that just needs to move around and doesn't really do anything for rotations. In that case, literally any shape will do. Now I'm also thinking for the termination. So what do we want? And I'm sorry, this stream is gonna be a little bit slow because I am sleepy and I'm trying not to do damage. So going by all the functional stuff we said before, what do we care for a guide? We would like to be able to definitely determine the length of the bones. So we would want to produce a first length, the length of the tibia and the length of the femur. So And let me bring these more in. So definitely that. What else do we care about? I said the length of the the tibia. Do we care about some angle? The position of the ankle, we will probably, the positioning of the ankle, we're gonna guide the IK and let the FK ride on it. Positioning of these will probably get from the leg global. Now it's not, if you ever wanted to use your leg component with something other than a leg global driving it, you might need an object in there and go like, when you guide two together, you know, you'll connect them. I will say that for now we're gonna save ourselves that pain. We definitely want to guide the offset from whatever its parent is. So the parent frame, don't need that serif. We definitely want to be able to configure that, and the parent frame will basically be some parent plus the offset. If we're guiding the IK, as we get the two lengths by moving some other object, we could get the rest angles as well if we need rest angles for anything. When you think about it, the FK itself is a function of a root and an end, possibly an up vector, and the length of the bones you have, and that's it. So the up vector we move to the leg global, and as I think I've said before, very often I will merge the foot and the leg components into one. In this case I'm doing them separate for several reasons, most of which I can't remember, some of them didactic. So I guess that's pretty much it. I mean, there's not a lot more than that we want. So let us be diligent and have a look at the input. So from the leg input we have the ankle, and that is coming from somewhere around there, I would imagine. Limited length. I was wondering if we're limiting that already. It's very possible that we are. We should probably diagnose that. So that is inward space. Let's have a look at that as well. Leg hip SRT. So this is, okay, that's rotation, good. For a second I thought we were connecting to the translation of that, and I was like, that does not make sense. And limited length, I'm wondering, my daughter overdrunk. I'm wondering if we do need to limit there, or if we were already limiting before. Doesn't seem harmful to have it, like we might be wasting a few cycles. We'll have to make a note that we potentially need to optimize that. So yeah, let's annotate that. This is gonna be super tiny for you. I don't think I can. Oh yeah, I can. Look at that. And it's gonna be behind the webcam. What I did not know at all is that there's a note editor. Damn it, you can't see it. I could resize my, I guess. There's a notes editor in the attribute editor for this attribute, the notes one. And it turns out that with control scroll wheel, like in all the other editors, you can actually resize the text. So the text. So check if nodes upstream already offering, what is it? Okay. So there you go. Control scroll wheel, magic. And it's gonna disappear behind the webcam again. So copy tab, like this is one of the things you can't trust. String attributes, like if you modify them in the attribute editor and you have a tab copied, they will just not update in my experience, as won't some messages when you connect them, and that one is actually pretty annoying. Copy tab, like don't trust it too much. If you're doing anything and using copy tab to keep an eye on values and stuff like that, it's a good idea, but if something looks really weird, don't instantly think that you need to debug everything. Make sure it's not an issue with copy tab. It's not 100% reliable. So we've done absolutely nothing yet, and we should probably start doing something actual. So what do I want to do there? Probably don't care for buffers for those controls. Let's have a look at the offset. So start word is the one that is going into a bunch of things. So this is getting an orient constraint kind of thing, which we're doing with the, this will be receiving our aim constraint done with the angle between, I imagine. Yes. Like limited ankle, ankle displacement, hit word SRT. Let's hook something up to that and see. That looks like a good first step to guide something. If you made it this far, I salute you. Like if you haven't fallen asleep or decided to quit this one. But as I said, I gotta be careful not to do damage or too much of it. So okay, that seems to get us what we want. Now that is receiving, okay, so we were doing, now I also remember that we were doing the, okay, that wasn't too bad. We were also doing the offset for these in the underword, I believe. Or were we? Heap offset matrix, output end. God node heap offset matrix. So we could, not loving that, to be honest. So this is the underword, and if you look at it, it's God node and leg. We should probably call it leg left in this case because we're going to that. And the debate we had at the time we added these was like, do we want them in the underword, so between inputs and outputs, or do we want them somewhere else? So this is all stuff that's under the output. We're okay with that. Slowest stream ever, isn't it? Let's get rid of that. I am torn. Let's see if we're using that anywhere else. We're using it for a couple things, aren't we? Yes, we're using it. So to keep these consistent between the leg input and the leg global, we decided to put in the underword, which will make sense. The other thing we could be doing is actually put this inside the leg global and then from the leg global go to the leg. Now this makes it a little bit harder to guide things because it comes into the guide already pre-configured. We can add CRUD to have a second offset, but then it will change the parameters for the length and stuff like that. Decisions. Hang in there, man. Yeah, no, I'm okay, to be honest. It's like occasionally you do need to go and do these inspections. I will normally do them off stream and maybe have a couple notes, but I've been asked to do this kind of stuff on stream more, recaps. So what are our options? We could take the underword, move it into the global, and output it to the leg input. Then the leg global, which right now offers guide elements for mostly for the foot, could actually at that point offer the guide elements for all of the FK. It's starting to become like heavier and heavier in terms of like the leg global is doing more and more for the IK, which is why I often just end up joining the foot and the IK, because it's just you always end up in this scenario basically. What do we want to do with that? It makes our guiding somewhat uninteresting basically for the leg. I guess we can just go ahead with the parts that we know we want to guide. So we know we want these. Parent frame we might actually not even need. We'll see. Length femur and length tibia we do need. Yeah, it'll have to be that. I guess it's a good thing, maybe, that our job is turning out easier than we expected it would have been. This is super boring. Like literally, like if this is coming from the leg global and this is coming from the leg global, all I can add to the leg guide is one middle element that will determine the length of the two bones, and that's it. It's like this guide is gonna have one element to it, and like the equivalence of like all these circles for the fit. There would have to be one up there for the leg global. So boring, but what can you do? I mean, it's we were too good. We have been too diligent and clean in doing this, if that's possible. So do we have tibia length and stuff like that? No, we don't. We would have them. I'll tell you what. Now watch me as I have those in the leg global as well. I bet you that we had them in the leg global. So do I have them here? No, I don't have that yet. Is it bad practice to provide a pre-offset heap output within the God node component? Look, nothing is better good practice really, in a way. I don't find it a good idea, because if you think in terms of like what was said before, where if you think of your components as giant functions, and they should be ignorant of how they're used, the God node itself is only interested in providing 1, 2, and 3 positions with their offsets and rotations and all that. It's, you know, three doublets of transforms. If something wants to hook itself up there for the God node, that's none of the God node's business, because the arm will instead need this one, and then we'll need the offset there. The other thing is, if you have a God node, chances are that you have a parent switch, and then it's going to be at the leg or arm level or whatever it is that you're attaching to the God node. So if you provide, how do you switch that space, right? Like you will need the offsets for each space that you want to support. So if you're attaching the leg to a God node and you say, look, this leg can be switched to the word space or to the master space or whatever we call them, or to the CUG space, you will need leg specific offsets from these, from that, and from that. The arm will need very specific offsets for all three. They both need their own enum to switch. So when you really look at it, that offset isn't really a term in the function of the God node. It's a term in the function of your leg or your arm or so on. And it's a guidable one. So if it was a polynomial, you will find it to be, you know, one of the invariant parts of the polynomial in front of a term. Now, and that is what, you know, it's kind of like what we're struggling with a little bit. By making the link between both of these, to keep that consistency, by making it part of the underworld, in a way, we are closer to having provided it from the God node than we are to having it in the leg. And then you go, oh, now I need to keep consistency. So that's a trick. Well, we did it to keep consistency, but now if we want to move things to be guidable, we have to shuffle around a bunch of stuff, which is okay because they're very early connections. You know, you wouldn't pay much in performance price, but it's the kind of stuff that we're trying to figure out. Now, what I want to figure out is if I did add the... So I guess the title of this episode is gonna be rig inspection, because that's all I've been doing in so far. I have memories of having added something, config parameters in the guide, possibly. Yeah, there you go. Tarsi length, tarsi rest, toe length, ankle rest. So that doesn't seem to have silly things. Tibia length, okay. Femur length, okay. Are we getting those from anywhere? That's my question now. No, we're providing them straight up. Femur length and tibia length. There you go. So we're doing the limit work. Oh man, this is actually a fair chunk of work that we might end up having to do. I am now debating whether I want to start on it now. I would like to do this kind of stuff in one single session. So I am convinced that we've been, and I'll need to look at it further, that we've been doing the limiting in the leg global right away, which is not necessarily a very bad idea. But femur length and tibia length. So where are we going with? I'm sure we're going to a limited sorts. Okay, so this is going into the leg config. There you go. Yeah. That is interesting. We really should be moving that stuff outside. So there's a not huge but relatively biggish refactoring we might need to do. And the reason we have those elements is that we do need them for the IK solution. But that is in the legs, so we're good. So this is leg global length limit. No, there you go. This is the stuff that we most likely... Is this on additive? Yes. This is the stuff that most likely clamp displacement. So this is still in the leg global. Our naming is saving us here. That we should move to the leg. So we should transplant this to the leg. Leg global limited ankle. So what we're doing, to cut the long story short, like this is what I thought we were doing, to be honest. Limited ankle, up vector, up vector. Sorry, I got distracted by my noter. So this limited ankle is gonna be, let's move things around a bit. It's coming from the leg global, and this is the word ankle rolled. Oh, I do have keys on that. So we're providing two things. We're providing this which is definitely a property. You know, it's correct that it's a term of the leg global because it's coming from the roll. And then we're also limiting these. And I can't think of a good reason. Let me see what it's connected to. See, what we're doing here is getting these, which is the limited, and the limited is a property of, you know, these items. We're doing that and moving it straight up to the output, and then from there it goes. What is this input? Do we have, yeah, foot input? Oh, I see what we're doing there actually. We're moving it to the foot, so we're getting a chance to do the foot work, no pun intended, early on. That is why. So the smart thing to do here will be to also rename these to our new naming convention so we know what the hell we're doing when I see them in the graph. Do not care for that. Do I have my shortcuts? Yes, I do. Diagnostic, okay. We can live with the god not being called like that. So, on one hand, I kind of like these. I like that we can do the evaluation for the foot before we even start working on the IK, basically. On the other hand, there's a fair chunk of work here. Like if we look at the evaluation for things where the leg cannot start anyway until it's received the already limited ankle from the global. And I'm not really 100% sure that that's a good responsibility to delegate to the leg global. Is this making sense to people, like why I'm doing these? Beside the fact that I'm sleepy and I need to avoid damage. Like occasionally it's good to just take stock of what you've done, and it's equivalent, if you were writing code, it's equivalent of going and doing some refactoring. And that's why I'm saying, I've been saying before, if you can do a guide early on, once you're more or less satisfied with the component's layout, it's a good thing. You'll take your time, but it is gonna poke and prod at what you're doing and how you're thinking of the problem, and it will sometimes put in question what you're doing and whether your responsibilities are correct. So we're not doing anything stupid here, to be honest. It's not like we have a terrible setup. It's just that while you want to guide it, you go like, part of it is me wanting to show something for the leg guide, which in production will be an absolutely stupid desire to have. When you're, you know, doing something that is basically an educational stream, it becomes a little bit more important. Part of it is that, like, having the right responsibilities on the right components is actually pretty important. I don't think, and so let me, since this has become pretty much an inspection and theory stream, so what we're doing there, which might or might not be a good idea. It's not a bad idea. It's neither, actually. You can go about it this way. You can go about it many different ways. So I'm trying to sort out my tablet. Sorry. So what we are doing there is basically doing the foot. Then from that, we're producing, you know, I need to make more space for myself. I don't know why I'm so conscious of real estate. From there, we're producing the limited ankle. So if you're talking about processing the graph and going parallel or not, like this, even if you don't know much about multi-threading or whatever goes on in your CPU, it should be fairly obvious that these two things for now are serial. They're in a chain. Like the limited ankle needs to be produced by, sorry, why did I write foot? This is confusing. What I meant with these is the leg global. By producing it in there, we're then going out to the IK as well as to the foot. Now, in a way, like if you think of it this way, you could think of this being one CPU working on this. Then once you get here, because the IK and the foot depend on that and on nothing else, you know, say your computer has 8 cores or whatever amount of cores it has, then you will be getting a layout like this. So you go, okay, this is a chance. The more work you do early on, provided you don't do too much, and that work being somewhat serial. This is you know, like this is a fault model approximation of things. The reality is that the multi-threading is finer grained than this. But for the sake of discussion, so if you do some pre-flight work, you get to work on more things in parallel quicker. Now, that is still not a super great idea when you look at all of the dependencies, because the reality of things is that it's not quite like that. It's more like, let's just call it global. We do have that global, and we do have that global doing the work for the limited ankle. And yes, that goes into the IK, but full. If we're using parallel where there's no digi-dirty tricks or anything like that, the foot might actually need to get, the foot will need to blend between IK and FK. Right now we're writing the FK on top of the IK, but eventually it will parallel. Now that global requires the God node before it can be evaluated. The God node is the one that provides us with the heap position. That God node is all that is needed. My daughter is very angry at the God node. That is all that is needed to start on the FK. But the foot, to be able to get both the FK and the IK, actually needs to depend on the IK. So by moving this limited ankle into the global, so we moved it in this space, because this chunk here is likely to be a fair bit more expensive than this, so it will take longer to evaluate anyway. We haven't really gained much of anything. So when you look at the dependencies this way, it is absolutely irrelevant whether this goes into the IK or in the global. Like, this is your chain of evaluation. So in terms of what component it belongs to, evaluation-wise, it doesn't make much of a difference. We could choose to have it in the global, or we could choose to have it in the IK. Now, what we did see... Oh, no. Need to switch shortcuts. Like the fact that space, like in one I navigate with space, in the other with Alt, always catches me by surprise. Now, what I was saying is the leg input uses it, the foot input uses it. And that was a convenience thing to get started right away, but we didn't, when I did the foot, we didn't have the IK and so on. So I reckon that in many ways, this is somewhat ancestral. It's stuff that needs to go. The tarsi length coming from, and a component can receive from more than one place for the record. So there's nothing wrong with getting the tarsi length from the leg global and the ankle from somewhere else. So these hopefully still make sense to you guys. I reckon that for some mental reordering of these, all we have here for the foot is these items. So let's start cleaning that up. Let's see if we can do some good work. Again, I hope this makes sense. It's been a long recap of what we're doing. But I don't know. I feel like personally I needed it. I always need to move faster than I can think on the stream, and it's good for me to occasionally catch up to this stuff. If you're watching this on YouTube, I would actually, and you made it this far without falling asleep, I would actually be interested in knowing what people think of streams like these. They can be too often, because like this is deadly boring, but I don't know how useful they are, how frequent they should be, or if they're even useful at all for people. this is the equivalent to somebody reading code without writing any code lines for an hour, which happens fairly often. So for this to make sense, what we really want is the start matrix to actually come from our leg, and then things will be much improved. Now, in that leg, do we have an output? We do. Are we doing anything with it? We're not. So the first thing we should be doing is actually add ourselves an output. So leg output. Sure. Do I want to really call it ankle? Like, it will be the end matrix of the leg. Now I'm trying to think. It will be in word space. In the other place, I'm just using a matrix. The control is in there, so it's doing some reordering. Okay, I'll go over the graph and what I'm thinking. So, not a great name, but it will make sense. And for the record, like, whenever I chain, I don't necessarily think of IK chains. So don't be confused by that. I don't mean to call it like this to mean, oh, it's the end of the IK chain and that's it. For me, a chain is a transform chain, so it will include the blend. Now, what I was thinking about is like the one thing that it's important that we take stock of is what are we doing with these matrix, if anything at all, because that will make a pretty big difference into what we do later on. So we are getting rotate, scale, and translate, and so on. Now that means that the reason we do it, so like this looks a bit wonky when you look at it like this, but it's actually kind of correct. So if you, no, yeah, it is. Because this is the ankle, so this is roll. It will help if we move one control, if we added a shape to show where the plant is when you move this, but for now that doesn't matter all that much. Anyway, the thing we're doing with these is that we're also from that getting the rotation. No, we're still good. Because if we get that, like if we literally transplant that stuff, which might be as simple as redoing a few connections and renaming a few nodes into the IK end of things, sorry, into the leg end of things, then we should be good. We might need to produce things in word space. Okay. Can I get that transplant done in the next 10 minutes? Say the surgeon. You don't want to hear your doctor say that. It's okay if Rieger says it. If your doctor says, can I get a transplant done in 10 minutes? Yeah, don't get anesthetized. So, chain end. We want it to receive. I'm half tempted to go half hack here and do things quickly. At the same time, I'm terrified of the damage we could be doing, since we say we want to be diligent and careful and attentive. Now, leg global, toes. Leg global, okay, for a second, I was very scared. Because I was like, this is leg global and it's inside the space where I have the leg. So this is all leg stuff, we're good with that. What we're doing here, TBN. So that is oriented to the IK, which is kind of okay. The form, however, should be in better shape. No, I still oriented to that. So here's what is missing, and that's okay for the record. This is outputting the leg, not the foot. So it is correct the way it is aligned right now. What we want and what this is doing is basically taking the roll and all of that and factoring in the orientation of that, both as a parent of that rolling element and therefore as the general orientation of the foot that we will be getting. The interesting bit about this is that then we will also need, for the FK to work properly, we'll also need to extract the difference between the default positions. And with that I mean that if our leg goes down that way and this is our ankle, this angle here as a rest angle is interesting because the IK will sort of take care of it by having that control here and using that transform. But the FK, being a straight up inheritance, does not really have that control. We could add it, but whether we add that control or we straight up hook and offset to the foot, you need to know this angle or this angle. They're kind of the same thing, as in they serve the same purpose. So if we wanted to add a mid control to the FK to go out like that, the ankle, yeah, we need to know these, and this is the rest angle. So that's also something that the leg global will need to output. Hopefully this is still making sense to everybody. It is dangerous to do these in the last few minutes of a stream. I'm almost tempted to call it here. Now let me get at least a couple of things going so that I know what I wanted to do. Kind of like notes to myself, I guess. So the solver, I am so torn about these things. I am so very, very torn. I could start by hooking these up. Do I have it in there? No. So let me add it to the global graph to begin with. So let me pin that. Maya is likely to teleport these into some very distant part of the universe when I add them. Yeah, no surprises there. Oh, come on. So those were the two parameters we added before. They were not pinned, which means they got moved to a galaxy far, far away. Then joined 1, 2, and 3. Okay. Do I want to treat them as something that can go straight into an output? I will say that I'm gonna be a cheap ass on this and actually do that. So as we go, like, it's vanilla Maya is different than if you were to build a pipeline for yourself. Come on. But and it's different again if you like compared to building a pipeline for an entire shop. So we said before that we're going like, okay, for our components, we're okay having an input. That input can go to some inner stage of the guide. This is our contract as far as the interfaces go. That in turn can go to the mechanics of the rig. So this is the inner the component. This is the literal inner working of what is going on. Somewhat inner to that, you have, oh, come on, I can do it. I can do it. You have the anim controls, which, well, actually, you don't want to, as I was saying before, you don't really want them to be overridden by the guide because it confuses things and it makes some things fairly dangerous. So this is an option. This is an option. You will have your spaghetti ball of nodes in here. And we say, look, these can only go out to an output. And only an output can go out to other nodes and only to other nodes inputs. And I'm saying other nodes, but what I really mean is to other components. So this is the contract that we've established. Now another part of that contract, which we only sketched, was we're gonna have a deform output, and that can go out to, let's say, you know, your stickman mesh. So, and this is all that will deform that thing. If you're familiar with ghost rigs from gaming of old and stuff like that, people often split the entire rig in a deforming hierarchy so that you could export it to a game for FBX, and a control hierarchy with a lot of duplication. This is not super terribly different, like you want to split the deformation from the rest, but what we're saying as well, because there's no real conflict with what we're doing, is let's say that we can also do this. So an output can be produced by the deform, but we also say that this is the order of our interface, that you cannot go from the output to the deform and then out to somewhere else. So we establish that clause for ourselves, fundamentally to be lazy about these. We'll see. I don't think we'll pay for these in a simple scenario like the one that we have. This is already blended between IK and FK. Right now the FK is riding on the IK, so it doesn't matter all that much, but it saves us from having to do the blending twice or having to carry from the blending on. It also means that we need to evaluate this chain before we can go out to another component. If this was much more complex, you know, we might look at shuffling that around, but for now this is good enough. So we're producing an output for these, and I have not saved once. I haven't done anything anyway, so I will say that this needs to change name as well. So we're literally refactoring at this point, and we're not touching the interface, which is good. If we had animation in this, nothing will be broken, because all the controls stay exactly where they were. So we're mostly, well, refactoring the leg complex, really. Oh boy. This was long-winded and boring, but I needed to do this, actually. I'm glad I did it. So I said that this week I would have liked to finish the leg and start on the guide for the leg, maybe finish that, though I didn't see it as a likely option. Like, it didn't seem likely that I would have finished everything, including the guide and so on. So it looks like we're gonna be getting stuck into refactoring the leg. Not sure I can refactor the whole leg and get stuff done by the end of tomorrow, but we'll see. Now, the other part I'm interested in is the foot. So I have a leg output. I want the foot input clean and set to 1. This usually works really well. Like if you clean a graph and you select an input and output that you know you want to work with. Actually, let me select just the stuff I want to work with. So you go from the leg output to the foot input. If you set this depth to 1, I can make this bigger, but it's just how many nodes, the distance you want to travel. Yeah, you can reduce and widen if it's already stuck. Normally you get a pretty good view of whether you can connect to things. And let's make these a little bit bigger. So I want to go from the output to there. Now I fully expect leg global config parameters. So we say that we were allowing for this shortcut, which eventually I would like to get rid of. This is basically saying, hey, there's a parameter in the leg global. Instead of having to go all the way to the leg global output and then go in here, we consider these parameters constant, so we're saying it's okay to shortcut those things. Leg output, chain end, we will want to leg global output. So these should actually be okay. It should just change the orientation of the foot. Yeah, there you go. What it has done is basically put that into some kind of odd angle where before we had this orientation, which was considering the ankle and everything. It was not changing the orientation of the limited ankle itself, other than in the space of the parent. Now that has basically ended up being in this space instead, or something similar to that. But the mechanic itself should still work, to be honest. There you go. It's just gonna be at an odd angle, so we're okay. That looks like somebody did some serious bodily harm to this creature, but it's actually more or less what you would expect, because we're going down the Z like that. So there's a pretty big change in rotation compared to something like this. So if you notice, it's more or less that angle there is being added to that offset. Okay. We will need to do better. We will need to, put together the limited ankle stuff into the leg, but that's okay. I really want to get on with this, but I gotta call it. So any questions, anything like that? It's been a very introspective stream, very zen. But yeah, if there are any questions, put them up in chat. I'm gonna possibly connect a couple things, maybe have a super quick look. See, this view is actually really good. When you do components that need to hook together, component Tinder, whatever, keep one master view that you keep in good order. It will eventually pay off. If there are no questions, I might actually call it right away and move the nodes tomorrow. I'm really torn about it. I really want to do it now, but I also need to go. We will look at the profiler. Never really got to fully comprehend it. Yes, we absolutely will. So a lot of sorry. A lot of this work I've been doing, and the reason why I've decided to do some of the things I've done is that yes, I absolutely, and it's also the reason why I introduce, some graph theory and stuff like that, and why I'm starting to drop in notions like these, is that eventually by the end of the season I would like to have covered evaluation. As for the profiler itself, it's not super hard to, if you want to get started on it, if you don't know what it is, the profiler is basically going to tell you the performance of your rig. The frames per second of your rig are not terribly relevant. I mean, they are as a final result in a way, but they're not really very informative. Whereas the profiler is going to give you much finer grain information. And it's all laid out instead of having to look at a single number. So the basic idea, if you're in parallel mode, is you gotta have a couple function curves, which we do have. You gotta move across the timeline, so with a play or jump in the frame, so long as it's a time change, start recording. Yes, I want to overwrite. You can jump the timeline a few times if you have a fairly simple graph, and you'll be okay. If it's a very large rig, you might need to increase the buffer. To give you an idea, we've done, 5 or 6 frames, and we're using 0.7 megs. This is a small rig to actually track info from. Set your view to what you want to view. So category view is kind of winding and winding a stack. It's pretty hard to understand. The one that most people understand more immediately is the thread view. That is basically telling you, hey, this stuff is getting divided over the threads in your CPU, which are not the same as cores. Very often, if you have an Intel with hyper-threading, you will see that you have twice as many threads as you have actual physical cores. And that means that some of those threads are really not that fast, but that's a different story. You can also have many more threads than you have CPU cores, but I think Maya in this case will tend to show you, like it will tend to align pretty closely to your CPU. So they're kind of like not really the same as the threads in the operating system. And that's it. So you choose a frame. It's not like the UI needs a lot of polish, to be honest, but the general notion and how it works is extremely useful. So if you choose a frame, you can go A for frame all. It's the quickest way to get around it. You will see a lot of stuff that is viewport calls, so you'll have VP2 calls and so on, update UI. You can turn those off. Record view all categories, so you can also not record these things. Like that, it doesn't make a lot of difference. It's not like you're paying in performance or whatever. Otherwise, it will make it pretty useful, but it makes a much bigger difference when you want to turn things off. It also decided that it should select stuff. I said whatever. But yeah, if you want to turn off Qt, VP evaluation, Bifrost is not really doing anything here. Dirty propagation you want to track. The main, yeah, sure, keep it. Anim UI refresh, Bifrost container, don't care for those really. And I remember that actually used to update there. I don't know if I have to re-record. That doesn't make sense. You used to be able to turn off. No, it's still in there, so it might be some other options. Anyway, it doesn't matter all that much. Come on. So what you're really interested in when you're rigging, for the most part, is these two brick colored, sienna colored nodes. And they are basically sorry, some of the DG costs of it as well as the evaluation cost. So if you're like, this is basically telling you, okay, you're blazing on one core, and it's taken 4 milliseconds, which means the rig is running at about that. Over that thread, the evaluation would have run at about 250 frames per second. This thread is getting hammered by all the general maintenance stuff that Maya needs to do, all the application loops, the viewport loops, and so on. So you can pretty much ignore it. Not much you can do about it. Your evaluation stretch for the rig itself looks to be like, oh, come on. How hard can it be? Okay. Looks to be more or less, it was just, it's once you have stuff selected, shift select will not, or control select will not marquee anymore, which drives me insane. If you select that bunch of stuff, which is pretty much the nodes that you see in here, you get a time down here, and I can't, like, this UI on a very high resolution monitor is gonna make you blind, something serious. But it's telling you, look, this took 5 milliseconds to evaluate, so it's about 200 frames per second. It's a super simple rig, so I mean, nothing surprising about that. And then you can do things like searching, which somebody was telling me seems to be half broken in 2018. So, but in example, I have the expression here, and you hear, oh, expressions are slow for this and then, and say, well, we'll get on, you know, we'll talk about that at some point, I'm sure. But it depends on the context. To give you an idea, come on, frame, that expression itself, if you do expr and frame, it is one of the most expensive nodes we have, but it's really not in and of itself. With a good run of the evaluation, it's really not that expensive. Like it's at about 97. This is not a U. It's kind of an inverted single leg then without a serif. It's a great letter and it's microseconds. So the expression is evaluating in 97 microseconds, which is 1/10,000th of a second. So it's not too bad. Don't worry anyway. So I will do a fair chunk of this stuff. Like this is pretty important stuff when you care about performance, and the profiler is absolutely key to optimizing your rig and knowing what is going on. And I reckon with that I've burnt out the time, but it was a good question, and I think it's pretty important. I don't know if anybody like watching on YouTube has made it this far. Like most of the Twitch chat has, which is impressive. Most of the people that were on at the beginning are still here now. It's a gem for the people that made it through to the end of the video. But yeah, you can start playing with it. Like, does it make a little bit more sense now what it does? It's literally taking each of these nodes, going like, hey, this has taken this much time to evaluate, and it tells you what CPU threads they end up on. So what you saw there is a pretty literal view where each lane, where each lane is basically, you know, one CPU core. It's what I was saying before. Cool. And some nodes end in here, then they go out to some nodes in here. Now, if nodes are serial, like they depend on each other, they need to probably be evaluated in a sequence. You can't really put them in parallel, but if you have dependencies like that, then you can see basically how this gets parallelized. And these really become islands of nodes, to be honest, or clusters if you have something that requires disentangling and things like that. And then you have staggering, where you go, okay, you know what, if this node also happens to depend on this one, and this is what I was saying before, it needs to wait on both these and these, so whichever of these finishes later, you know, you end up with this staggered aspect of it, and you might end up with the thread, like if everything else is chock full of stuff and there's nothing else to evaluate, this depends on a lot of stuff, that becomes a bottleneck where you go, well, everything needs to come down to this node, and this is all wasted CPU basically. This will happen, it's inevitable, but you want it to happen as little as possible. All right, with that I am really for real done. We will do is, like, all of these will be repeated and done in context properly, and we'll talk about profiling and how parallel evaluation and DG work and interact with each other and so on. All right, hopefully that redeemed the stream. The gem at the end, reward for the people that made it to the bitter end of this stream. And I'm definitely calling it out. I don't know why I'm even saving these on stream. There's no need for that. All right, thank you very much for watching. I'm out, and if you're following the stream, I will see you tomorrow. If not, if you're on YouTube, you will see me whenever. I don't know. Might be years from now for all I know. So yeah, have a good day.